Hello, so this is the demo for the numpy foundations for deep learning notebook. Yes, so this notebook is basically giving us the idea of foundations in numpy and how it is used in deep learning. So the first thing is matrix multiplication. So matrix multiplication is basically element by element multiplication, and here it shows that if it is a 1 cross 3 and 3 cross 1 matrix is multiplied, you get this scalar values. Second is if you multiply 2 by 3 and 3 by 2 matrix, again you will get a 2 by 2 matrix. So it's basically, if you can see here, these are the shape. So 2 by 3 matrix matrix at the rate is defines matrix multiplication in numpy. So here when a 2 cross 3 matrix is multiplied with 3 cross 2, this 3 gets cancelled and we get output in a 2 by 2 matrix. So this is very important. So these two numbers should be matching for a matrix multiplication, because this element will get multiplied with this plus excuse me, I'll explain it over here. Say 1 cross 3 and 3 cross 1. So 1 multiplied by 7 plus 2 multiplied by 9 plus 3 multiplied by 11, and that is how you'll get this one singular value. Excuse me. Same over here, 1 into 7 plus 2 into 9 plus 3 into 3 addition, it will give us 58. Same 1 into 8, 2 into 10, 3 into 4, it gives us 64. Then 1 into excuse me. So like that this matrix multiplication works. Yeah, here also it explains that if a matrix is m cross n and b matrix is n cross p, the output will always be m cross p. Yeah. So yes, matrix multiplication is heart of neural networks. It is a very important operations. As we know that the inputs are multiplied with the weights matrix and then added with the bias, and then the activation function and all that happens, but this is the main operation. Yeah, so dot product is basically element by element operation. It works when it's a single matrix, but a single vector. But when we deal with higher dimension data, matrix multiplication comes into play, and it's a specific mathematical operation that combines entire rows and columns. Yes, so here we'll explain how it works in neural networks. So this is the main formula for neural network, is weight into input plus the bias. So we are randomly generating the input values, the weights, and a bias. Bias is a singular number an array of 0.5 and minus 0.5 has been defined. So I'll explain the output. Yes, so the input matrix is 2 cross 3, weights is 3 cross 2. As I mentioned that the inner number should be same for the matrix multiplication to happen, and the output will be 4 cross 3, and here the bias is 2 cross 1. So first we'll do the matrix multiplication. X multiplied by w, we got 4 by 3. Then 4 by 3, this is the z value. Then this z is added with the bias, and bias gets added with broadcast. It just broadcasts the value to the 4 cross 2 matrix, and we get the matrix as this. So broadcast doesn't change the size shape of the matrix. Yeah, we'll be discussing more later. So here you can see the output of the matrix, the random matrix which we created. uh, Here B is a vector that gets broadcast across all samples in a batch. So we're talking about the bias vector. So this is the matrix, this is the vector, the result is matrix plus vector. Let me go to the yes, so here it explains what the broadcasting means. So we have this matrix 3 cross 3, and this is another matrix, and what so yeah, it explains the broadcasting. Basically, this element gets added with this one, we get 11. This with this same element addition, we get the values. As you can look, for all the others it is the same. So here we have this matrix 3 cross 3 matrix, and this is the row vector 3 cross 1. So now when we add these two matrices, let's see how the broadcasting works. So how it will work is this whole vector will get added to this vector, and the another vector. So this is how the broadcasting works, with different shapes, if there are any. So here it was very simple that it was this was in a 3 cross 3 same matrix, so the element wise addition happened, but here the shape is different, so this whole thing will get added to a single vector, and you can see the output here. Yes, and then this is the very simplest broadcasting that can happen. This is a 1 cross 5 matrix, and this is our bias. So each element is getting each element of the vector is getting added with the bias. So this is how the broadcasting happens in a very so there are some rules. So the arrays are compared from right to left. Dimensions are compatible if they are equal or one of them is 1, and if an array has fewer dimension, it is padded with ones on the left. Excuse me. The magic that makes neural network work, that's broadcasting. It allows numpy to perform operations on arrays of different shapes. This is essential for adding bias, when we add the bias to the output of the vector multiplication, matrix multiplication, and it is also applicable while normalizing the data, applying operations across batches. So without broadcasting, we'll need a lot of explicit loops, and we hate loop, we don't want loop. It degrades the efficiency. So now we'll move to the activation functions, different activation. This code is just to plot the different activation function. So first we have sigmoid. This is mostly used for binary classification. So it basically scales your output to 0 to 1 probability, whether it's a class 0, it's class 1. The probability can be 0.6, 0.2, 0.4, like that. So it gives you a range from 0 to 1. So this is mostly used in binary. Then we have tan. Tan is basically putting the values between -1 to 1. Excuse me. And this is mostly used in hidden layers. Then it is centered around 0. Then we have ReLU. ReLU is it is very fast and very popular. We use it any if there are any negative value, it gets centered around 0, and if basically max of 0 or x. And so this can actually one of the issues of ReLU is exploding gradient. So and for these two, one of the issues is vanishing gradient. So we have, that is why ReLU is mostly used. But again, in ReLU we have to normalize the output, otherwise it will, uh, it will lead to exploding gradients. But then we have leaky ReLU. So it fixes the dying ReLU problem. So it allows negative values as well. Excuse me. So it allows a like max of alpha x or x. So it just multiplies this 0.1 to the x value if it's negative. Okay. Yeah, it's just applying the this is the input value, and we are applying different functions, the activation functions to it. So as I said, sigmoid uh, puts your output values from 0 to 1. This is -1 to +1. ReLU is 0 to max of value, leaky, and softmax. Softmax is basically if you have multi-class classifications, multi-classes. So it within those classes, what is the probability of each output? What is the probability of it happening? So it always sums to 1. Then these are the functions which are used for the activation function. Let me move to the then there are some mathematical operations, how they form some element wise operations. So let's say this is array A 1 2 3 4, array B is 5 6 7 8. So a multiplied by B is 1. The 0th element of this will multiply it with this 0th element. The index operation, index wise operation, element wise, also known as element wise operation, will happen. That is how we'll get 5 12 21 32. Yeah, so basically here just a basic numpy, how numpy functions are, so operations are. So this is if you want to add these two vectors, it will just do the element wise addition, element wise multiplication, subtraction, and a divided by b is again element wise division. Yeah, again this is again with the scalar value. That was again with the vector value. This is again, so one vector with the scalar value addition is like the broadcasting. It will add to all the elements. Same with multiplication, it will ought to apply, it will be applied to all the elements. Same with exponent and division. Then we have, these are the numpy concepts. And numpy has arrays and shapes, and in deep learning it is used as tensors and data for tensors, as tensors for data representation. We have this functionality as indexing and slicing. It is basically extracting some part of data. So that is used in batch processing, feature selection. Element wise operation is used for activation function. Broadcasting is for bias addition and normalization. Matrix multiplication is forward pass and layer computation. And the statistics and aggregation is used for loss function and batch normalization. Reshaping for flattening and flattening images and tensor manipulation. Random generation is for weight initialization and dropout. Yeah, we did that right now. Vectorization is efficient neural network training, and mini neural network is basically putting all of these together. We are just setting up the numpy. So in deep learning, all data is represented as multidimensional arrays, and they are called as tensors. So as we know, images can be represented as 3D arrays, height, width, and channel. 2D text as 2D arrays, sequence length and embedding dimension. Batches add one more dimension for excuse me. And weights can be 2D arrays connecting layers. So numpys are the foundation that PyTorch and TensorFlow tensors are built upon. Mm, yeah, basically any matrix operation can be done using numpy, and because as we know that matrix helps us handle and manipulate higher dimension data without increasing the complexity of the problem. So as you saw in the broadcasting. So yeah, that is the main reason we use vectors. Okay, let me. Yeah, it is just telling us the dimension. This is 1D array, this is 2D array, 3D array looks like this. Let me just see. Yeah, so 1D array is this, 2D, 3D is multiple layers. Excuse me. Then there are some special arrays like all zero arrays, all one arrays, every value is array 1, and there's this identity matrix. So yeah, where all the diagonal elements are 1. So yeah, these are the different types of arrays. And then a range is a functionality where you can create sequence of numbers in a numpy. So let's see, this is start, this is stop, and this is step is how many steps you want to increment. So let's say I want to start with 0 and it should stop at 10. 10 is exclusive, it's not included. And then we have step 2. So we want we want to start with 0 and then add 2 step. So 2 step each time. So it's like a range function in normal Python. So 0, 4, 5, 6, 8, and the other next number would have been 10, but as I said, the 10 is not inclusive. So yeah, it got ended at this. Same here, we can have line space. Yeah, so these are different data types. We can have a numpy array of integers, float 32 bytes, and float 64 bytes. Yeah. So as we saw that 2 bytes float is also there, 4 byte is also there, 8 bytes is also there. But this is the standard. This is the standard for deep learning. For GPUs we use half, and for scientific computing we use the double. Yeah, so you can see a multi-dimensional data, like tensors being formed, arrays being formed. Yeah, so this is the actually 28 by 28 pixel image data has been created, and this 10 is the number of images. So here we have created, and these are created using random numbers. So yeah, that is so basically it is trying to say that we can describe an image with a 3D vector and do matrix operations on top of it, which is neural network about. Then we have slicing and indexing. It is important because when we want to extract few columns or particular row, we use that. So it is for batch selection, feature extraction, training, splitting the data for training and test, attention mechanism. So yeah, so basic 1D array mein you can do as array 0. So it basically gives you, this is the index number, just give this. You can also slice it. Slicing is basically giving from where to where. So let's say this is 0 and I'll do this to 10, so it will slice. And let's say this is okay, let me do this 0 to 5, this is 10 9 there are 9 elements. So what this will do is this will give me first 5 elements. So like that you can slice the data. Yes, so this is positive index. Like usually it starts anything in Python, all the iterators starts with 0, 0 1 2 3, and length of the vector. And this can also be, there is negative indexes as well. So negative minus 1 is the always the last element. So whenever you want to extract any last number, we just do minus 1, we'll get the last element. And this is that increases 0 minus 1 minus 2 minus 3 minus 4 minus 5 till the end. And yeah, as I mentioned, that the slicing has 3 things: start, stop, and step again. Excuse me. So the same thing you can apply over here. The same goes with the matrix multi-dimensional indexes. So you can slice it based on excuse me. Yeah, here it's just explaining this slicing visually. So let's say I want to slice this one, I just do 1 comma colon. So it means only one row. So yeah, so when you are dealing with multi-dimensional array, it's just first is row and second is column. So how many rows you want is it's 1. A comma, it says colon. Colon means all the columns or all the rows. In this case it's columns, so we are taking all the columns. When it's matrix, so here you can see all the rows, it is asking for all the rows, but that it should take second 0 1 2 second column. And if you want like this, you can just do 0 to 2 rows and 0 1 2 3 columns. Like that it will slice it. Then we have boolean indexing also works. So you can actually add some condition to your arrays. Let's say you want to see what all values are greater than 0. It will just give you the true false value like that. So whenever you want to filter some data, you just slice wherever there's true, just get me those values. So boolean indexing is a really powerful operation. Then this is ReLU operation on top of that. Yeah, that is pretty much it. Yeah, thank you so much.